Alrighty, we'll go ahead and get started. Once again, welcome to Imubit's webinar, the 2024 Product Year in Review, all about the Imubit Industrial AI Platform and some of the explainability, collaboration, and new application features that have been built into the platform over the past year. I'm joined today by two of Imubit's fabulous product managers, Geraldine Huang and Rex Tan, who will introduce themselves in more detail when it gets to their demo portion of the call. I've got a couple of housekeeping items for us before we get going. Number one, this session is being recorded. The recording will be emailed to you following the conclusion of the webinar. You're invited to submit any questions that you have during the course of the presentation using the Q&A console during the presentation. Note that there is a difference between the Q&A and the chat. If you have any questions that you want answered during the Q&A, please use the questions section as opposed to the chat, which is used for more logistical information, like if you have trouble hearing or anything like that. We'll do the live Q&A at the very end of the presentation. So that'll be your opportunity to ask your questions and get live answers from our product manager presenters. And then lastly, we'll use polls throughout the presentation to help learn a little bit more about who you are, as well as your objectives and what you are interested in using the Imubit Industrial AI Platform for. So with that, we'll go ahead and launch into our first poll question. I want to know what your role in your organization is. So I've published that poll, and you can feel free to respond with your current role. Looks like we've got a couple folks representing controls, APC, optimization, some folks on the digital organizations. Actually, operations is leading the pack right now. Process engineering, planning, and economics. So really broad representation of different user personas joining us today. So I appreciate you all participating in that poll. And there will be more of these to come as we get into the meat of the presentation. So a reminder of what we're here to cover today. This webinar is all about the Imubit Industrial AI Platform and looking at all the progress that was made in the platform in the past year. So really a reflective webinar about everything that you as our customers pushed us towards and what we've done in response to your ideas and your feature requests. So I want to start off with the high-level Imubit platform vision. If you've ever seen a talk given by Imubit's VP of Product, you've heard this statement before. But the vision of the Imubit platform is to accelerate industrial innovation and value creation by democratizing AI. And when we say democratizing AI, we really mean empowering your domain experts to harness the advanced AI capabilities of the Imubit product and AI more broadly in your daily work. When we've brought the platform vision to life this year, we've witnessed pretty insane growth in user engagement as well as growth across roles in the organization. So whereas the Imubit product started off as kind of just the closed loop control and optimization application, the platform has really broadened the groups of people within an organization that Imubit applies to. So we saw a 120% increase in user growth over the course of 2024 in number of users interacting with the platform on a monthly basis, and then saw roles increase from process controls folks to include planning and economics, process engineering, operations, and even leadership in some of the different ways that folks are interacting with the platform. This growth in user personas and platform users overall has also resulted in a lot of excitement from you all as our users when you saw the new features that you requested come to life, as well as excitement from the Imubit team about your never-ending curiosity and where you're pushing us with the platform. Now let's take a look back at some of your most loved aspects of the Imubit platform in 2024. Everybody's favorite new use case, which is a little bit more of a qualitative observation, was the what-if simulations for operator and engineer optimization training. So using these simulations to look at different types of scenarios and how your unit would respond to different changes that you could make. The favorite UI of the year was the performance dashboards. And then I really love that the favorite features of the year, we've got this parade up for you, really play into that favorite use case and favorite UI with some of the key elements of that what if simulation and optimization training use case being adding manipulations and viewing notes. What you said about the platform in 2024, all about collaboration and increasing communication amongst teams. We heard from operators, we heard from controls engineers, we heard from process engineers that the Imubit platform facilitates conversations that weren't happening before and improve communication between particularly operations and planning and economics, and giving that higher level transparency into why somebody's making certain decisions about how they're going to run the plant. And then some of the features you asked for that we were excited that we delivered in 2024. There was around inferentials, comparing the performance of different inferentials. So when you're building your Imubit model, inferentials are oftentimes one of the inputs that represent some of the unmeasured variables that you would use. And our customers wanted a way to qualitatively and quantitatively compare the performance of different inferentials compared to their infrequently sampled or measured values. There is interactivity and directionality now in your shot plots. So again, something that's tied somewhat to the inferential component of the Imubit modeling capability. Your shot plots are giving you knowledge as to which of the inputs in your inferential carry the most weight and in what direction they influence that inferential. And then multivariate relationships or your process gains between your different variables over time. So sometimes seeing a time series trend of a singular variable is not going to provide as much insight as seeing a multivariate relationship and how that changes with time or at what periods of time your different gains are behaving different ways. So we're very excited to launch this feature as well as all of the interactive filtering capability in the model evaluation component of the Imubit platform that Geraldine will get more into later. And now I've got a second poll question for you all. I want to know what types of challenges you're currently using AI for in your organization. So I've launched that poll and I would love to hear your responses. If you've got other different applications that you're not seeing listed here under the multiple choice responses, feel free to add those details about the different things you're using AI for in the chat, and we'd love to hear more about them. Alrighty, it looks like we've got a good audience of potential Imubit customers here, with closed loop optimization and control being the leading answer. Also, some folks doing predictive maintenance and quality predictions. Some of the more common, I feel like, use cases for AI in the industrials. And then other, I look forward to reading more about that in the chat as we get to different portions of the presentation. So I want to reiterate that Imubit platform vision that we're accelerating industrial innovation and value creation by democratizing AI. And I think today's series of product demos is really going to highlight the effort that the product team has put into bringing this vision to life. Before we get into the demos, a reminder that the Imubit Industrial AI Platform is one aspect of the holistic solution, the Imubit Optimizing Brain for Your Plant. The Optimizing Brain for Your Plant is our end-to-end solution that includes not only all of the things you'll see today that are built into the Imubit Industrial AI Platform or the user experience where the majority of the users are going to interact with the process model behind the Imubit solution, but it also includes Imubit Deep Learning Process Control, which Rex will touch on briefly in his demonstrations today. But Imubit Deep Learning Process Control is that on-premise component of the Imubit software that actually manipulates your process variables in your plant through either the DCS or APC integration. Both of these elements of the Imubit product are propped up by Imubit's service component, so value sustainment services and workforce transformation services that are delivered by a team of former industry experts and domain experts in process engineering, process controls, and optimization to help you get the most value out of your Imubit product. And as I said, today, we're going to focus mostly on that Imubit Industrial AI platform. And I'm excited to show you all this series of demos that will be delivered by product managers Geraldine and Rex that dive into the explainability and collaboration features, as well as some things related to monitoring your controller performance, gaining deeper situational awareness, and also seeing what your operators see. So at this point, I'm excited to hand it off to Geraldine Huang, who is our product manager for model evaluation at Imubit.
Thank you, Allison. My name is Geraldine Huang. I am the product manager for model evaluation on the Imubit platform. My background is in chemical engineering with industry experience in chemicals and steam cracking. And I started with Imubit in 2019 as part of the implementation team, and then transitioned to the product team to work on the development of the platform. And as a product manager, my job is to make sure the platform solves your biggest model evaluation challenges and that you actually love using it. So if you haven't fully explored what it can do, don't worry. Today, that's what I'll be showing you, all the features we released in 2024 to help you get the most out of it. There were a lot of features released in 2024. But I would say our biggest release and updates to the platform were in the model evaluation module, specifically for each of the components of the AI models. For model evaluation, our primary focus is to allow users to dive into their newly trained models to understand the process dynamics and validate the optimization strategies that were learned by the model. The model evaluation module is what allows platform users to break open that black box and systematically analyze their own models to gain confidence in the models that they're building. So let's dive into model evaluation for a demo of the analysis that can be performed on the dynamic simulator model component. One of the key metrics for visualizing the dynamic process relationships learned by the model is with gains. Gains is a measure of the change in a dependent variable, which you can see at the top, based on a change in an independent variable, which you can see on the left side. One of the biggest advantages of a neural network model is that it can understand hundreds of thousands of these relationships per pair of variables, and then generalize them based on the process conditions or process state present in real time. So here what you're looking at, we have gain histograms showing the distribution of all the gains that the model learned during model training. And in this gains matrix, you can see blue for positive gains and red for negative gains. So you can quickly see if the model learned the expected process relationships. We've made these gains interactive, meaning that you can highlight a group on the histogram to see the corresponding gains in all the other gain histograms. So here on the total products and reflux rate gain histogram, there's a small group of positive gains that I'm going to highlight. And once we highlight, we're filtering the data. So you can see what gains it corresponds to on the other histograms. Here, your data is telling you a story about how all the data affects each other. And scrolling through, it looks like it corresponds to maybe some shifted relationships for some of the other variable pairs that we can look into. And while this view gives a really good overall view of the relationships learned by the model, I can actually pick one of these pairs and dive into a more detailed view. Maybe I want to see when these relationships occurred in the data. So let's go into detailed analysis. You can see that the same gains here are highlighted because of the filter or what we call query from the previous page. And it looks like most of these gains occurred during the first quarter of 2020, maybe a few periods before 2020. But you can see the bulk of the gains were learned from this time period. This is where domain expertise is critical during model analysis. Maybe in early 2020, there was a shift in operational targets, feed qualities, or change in catalysts that a domain expert could identify. And given this knowledge, the user can then determine if the model learned the expected relationships during that time period, kind of giving it a little bit more context. The data again here is telling you its story. And part of model analysis is to help you play with that data to better understand its story. In this detailed view, we have other metrics like prediction error and data distributions to show you prediction quality and process conditions that were included in model training. And again, these metrics are interactive. So one thing our users really like to do is to check episodes of high error to see if there are any concerns. I know the tail is very, very small, but you could see the updated highlights based on the interaction, so based on the high error episodes. And again, while this gives a good view of the time period, pretty evenly distributed across the historical data, we can actually view these episodes at a more granular level, actually comparing the historical data to the model prediction in specific episodes. The query or filter here again is the same as the previous page, the high error episodes we selected. And this page shows the time series charts of each variable's historical data in yellow and the model's prediction for that time period in purple within a control window. So now we're looking at a scale of hours. This page allows us to random through different episodes that match that given filter. And so here we can gain insight into what high error really looks like in this case. So as I'm flipping through some random episodes, the directionality of the prediction looks pretty good, even if maybe the prediction isn't straight on the historical data. But overall, I would say maybe we aren't too concerned about the prediction error here, just based on these couple of episodes I'm randoming through. I can also see that only about 0.5 of the episodes in training exhibited such high behavior or high error, which really isn't that often. No model is going to be perfect, but being able to actually see these high error episodes visually, we can likely say that this model has pretty good prediction quality. And if you want to get even more detailed, we released an amazing metric called input contribution. This metric breaks down the contribution of each model input in a dependent variable's prediction. So now you can go in and identify which input into the model might be skewing or highly impacting the prediction of the variable and compare it to your expectations. This allows you to really break down the dependent variable's prediction into its components. Okay, so moving on. In addition to giving domain experts the ability to deep dive and evaluate the models throughout model training, we've taken user feedback, spent time adding features that allow not just domain experts, but anyone from the plant to perform what-if scenarios, simulations, and even set up process training in the cloud. Collaboration tools were also built in so that users of the platform can share their findings in their simulations with their team and drive evidence-based discussions around model performance all in one place. So let me now pull up a reinforcement learning controller model in the platform. So in this offline cloud controller, users can adjust bounds, prices, and various model parameters to see how the model would respond to changing conditions without disturbing the live process. This cloud controller is very powerful for not only understanding the optimization strategy, but also to test out potential scenarios or for user testing. So here in this view, we have all our model variables, including the MVs or manipulated variables, the CVs, and the DVs. The purple line shows the model moves, so how the model would move the MV, and then on the CV charts shows the model predictions based on those MV moves. And then on the left, we have all the model parameters that the user can adjust in this simulation. So for example, if a process engineer was looking at this scenario or process state, maybe wants to set that cat naphtha bound closer to the actual product spec and lower it to increase throughput, they could reduce the bound here and compare how the model how the model response would change. So here we can take a snapshot of the state, lower the bound, lowered it to 8, and immediately you can see how the model would change its MV moves here, mainly pushing the tray 1 temperature up, maybe also pushing a little bit of the reflux rate. But with the new MV moves, the process engineer can see the resulting CV responses as well as the change in the overall objective function right here. So not only can the process engineer do all this analysis, you can also save it as a note. So let me add a new note here. Let's call it lowering RVP bound, and hit save. And with this note, we can come back, view it later ourselves, or even send it directly to another platform user to maybe start those evidence-based discussions on whether we can start looking into lowering that bound. Other examples could include planning and economic engineers inputting future price sets in here to see how the model would optimize before actually putting the prices online. And again, they could save their findings here in a note, send it to the team, start those discussions, really get a feel for it before putting it online. So with the ability to simulate so many different scenarios, platform users are now using this cloud controller to train new process engineers or new operators on the optimization strategies and process responses. Loading a scenario for training is as easy as saving a note. So let me pull up a training scenario that I've saved here as an example. And as the scenario is loading, you can ask the trainee, look at the process state here, and with the olefin C5 spec in violation of the upper bound, how would you adjust the handles that you have, the reflux rate and the tray 1 temperature, to get the C5 spec back in range while still optimizing and increasing the objective function if possible? The trainee here can then run through different what-if scenarios based on their understanding. Maybe apply a manipulation to see how the spec can change. So here, let's ramp the reflux rate by 5 and see if that will get our C5 spec back within range. So I apply the ramp. You can see the ramp in orange on the reflux rate, and you can see the C5 spec is back in bounds. Maybe too much, Maybe we want to go back and readjust. So let's only ramp, let's change it to 2 and see what happens. So we'll change. And here you can see with a 2-degree ramp, the olefin still back in range, maybe a little too long, but maybe that's okay. Looking around, the RVP has some space here to its bound. So let's move the tray 1 temperature. Let's start with 2 degrees. Again here, ramp, hit apply. And you can see very quickly with the 2-degree ramp, this olefin C5 spec still good, RVP, and actually we've increased the objective function some here. And maybe we can say this is the goal, that we've achieved the goal. Here we only did 3 moves, but the idea is that users can perform many trial and error moves here to get a better feel and understanding of the process dynamics and optimization. And we can also make it a fun game of, did you perform better than the model would have in this scenario? And here I didn't, but you can see that what the model wanted to do is increase the MVs more, keeping the specs within bounds and actually pushing the objective function pretty significantly. So not only is the model evaluation module in the platform designed for users to evaluate and validate their own models, we've included so many features in 2024 that allow for collaboration, training, and simulation that expand the possibilities of what you can do in the platform. All right, back to you, Allison.
Thank you, Geraldine. Now, after seeing those awesome demos, I'm sure you guys are all thinking of, like, past me, process engineer me is thinking of, how would I want to use some of these what if simulation capabilities in my day-to-day job? So we've got another poll question for you. Interesting. We've got clearly some former process engineers folks in the house talking about calculating economics of debottlenecking projects. We've got some P&E folks wanting to make economics decisions on feed or yield, understanding of process degradation. There's so many ways that this simulation capability can be used to increase your knowledge of how the different variables in your plant work together. And we're excited for you guys to really start to get your hands on it. Now we'll jump into the second half of our demo series with Imubit Product Manager for Deep Learning Process Control and Performance Dashboards, Rex Tan.
Thanks, Allison. Hello, everyone. My name is Rex Tan. I'm the product manager for the Performance Dashboard and DLPC. My background is also in chemical engineering, and I previously implemented DLPC in models before becoming a product manager. My first demo today will showcase features from the Performance Dashboard. The dashboard is available after DLPC has been implemented and provides a high-level overview of your model's performance. So let's jump into it. So here we have the overview page of the model. You can see if your model is engaged here in green or disengaged here in red. Alongside these, you have the percentages here on the left for this time period. And you can also see the objective function here in the middle, whether it's increasing or decreasing over this time period. This is a powerful indicator for value generation at a quick glance. Down here, you can see if your variables were limited or constrained. Green means unconstrained. Yellow means we were close to the bound. In this period, it looks like we were mostly close to the bound. And red means bound violation. Up here, we can change the time range for the data. So it defaults to 7 days, but you can change it and customize it however you like. Next, let's dive into a scenario with the dashboard. So we can open up the notes here and find a comment my teammate left, or myself in this case. This is similar to what Geraldine showed earlier. So this is the detailed performance page where we can zoom into certain scenarios. So down here on the left, we can see the manipulated variables in blue. And on the bottom right, we can see the controlled variables here in yellow. So let's take a look at why DLPC was disengaged during this red period here. So if we look at the first MV, riser outlet temperature, it looks like it was increasing here after disengagement. And when feed rate also looks like it was increasing here on the left. And resid flow over here looks like it started to decrease there. So let's also take a look at the CVs. CO concentration looks like it was in violation here and up here. And the overhead flow rate looks like it was violating the upper bound here after disengagement. So it looks like a couple things happened. What we know for sure are the MVs and CVs moved pretty drastically after disengagement, whether it's because a constraint was coming into play or whether it's an optimization strategy change. It's a little bit hard to tell. But this page does help us build a picture of what happened. And we can do a couple of things from here. One is we can use the model evaluation, like Geraldine showed earlier, to show us what the model wanted to do during this time frame if it was engaged. Or we can check the events report from the previous page to see if anyone left any comments for disengagement reasons. So we can navigate back to the overview page. So let's go over the detailed events feature. This page allows you to see reasons for why disengagements occurred. Some reasons are automatically populated, and others are populated by operators using the DLPC application. So let's open it up here from the main page. We can see two reasons for disengagement here. The first one looks like it was a weather event, and the second one looks like it was some sort of instrumentation issue. So now we have the context for why DLPC was disengaged during those two periods. And if I actually had more context for what this weather event was, I can actually edit it. So I can hit the edit button there, and I can add heavy rain as an example. And then I could hit save. And now this comment will be updated for everyone who has access to this page to see for future reference. So I can hit close. All right. So my last demo for today will be for the DLPC application. Today's demos and conversations have focused on the cloud platform, but you also have the option to see a mirror of the on-site application and the operator interface. This DLPC cloud app will display predictions and settings like bounds and close to real time. And just to note, this mirror is completely disconnected from the running application on site. So we can get to the cloud app from this home page here. Yep, so if we click this button, the view only app opens. And we start here at the dashboard, where we can see an overview of the current state of DLPC. So we can see the engagement state of all of our models and what the availability looks like. The next page is the matrix page, which is a tabular review of the data. So here we can see the upper and lower bounds and the rate bounds for our variables. And this is what the operators see. So it's really just a one-to-one mirror. And here, the last page we have is the charts page, which is a time series view of DLPC data. And again, this is the same thing that the operators see. What is notable on this page is the predictions are available here in the dotted lines. So this is where the model wants to take the process. So for each MV and each CV, the model is predicting where it will go. So the operators can use this as information, and whoever has access to this view-only application can also see these predictions as well. This is a very powerful tool just to understand where the model thinks the process will go. And with that ends my demo, and I'll pass it over back to Allison.
Thanks, Rex. And thanks for sharing all that exciting stuff that came out into the performance dashboards and the view-only cloud app this year. So we've got one parting question for you all as it relates to the Imubit product. This question is when, not if, Imubit exposes the API to allow you to embed data or calculations into your workflows. What types of data or functionality would you like to consume? Now, this is not a poll question. This is a free-flowing answer. Feel free to put your answer into the chat, or we'll also provide you with the contact information for both Rex and Geraldine if you'd like to send them a private email about what you're interested in after this webinar today. A couple of areas for you to learn more if you're both an existing Imubit user or if you're new to Imubit. For existing users, you can dive deep into the training associated with the Imubit Industrial AI Platform through Imubit Academy. So the link is here, and my colleague Mara has also thrown these links into the Livestorm chat. And then if you're new to Imubit, we've got a couple of options for learning more, both about the technology that powers the underlying Imubit models. So that's the reinforcement learning and the different AI technologies. We've got a whole webinar series that our CTO, Professor Nadav Cohen, just did on this topic that you can access from the Demystifying Industrial AI link. And then if you want to dive deeper into the Imubit platform and get kind of a customized interactive demo with a live session with one of our product managers or one of our solution consultants, you can use the link to request a demo and we'll get that set up for you. Now, at this point, I'm going to invite Rex and Geraldine back onto the stage to answer a couple of questions. Awesome. So as you guys are thinking through questions that you may have as the audience, I want to get started with a couple of questions that I know I have every time I see some of the demos like this. And I'll start, Geraldine, with a question for you on, generally speaking, these DLPC models, they're built on data. And so a lot of times our customers are wondering how much data is actually required to build and train one of these Imubit AI models.
Yeah, so that's a really good question. So for these models, it depends on your data compression rate and your data availability. So one, compression rate, if it's highly compressed, will likely need more data, longer periods of data, and also kind of what kind of operating regimes you're trying to capture or process scenarios you're trying to capture in your model. So generally, we recommend if your data compression rate is not too compressed, and we're just looking at kind of normal operating regimes that you've seen in history, we recommend about maybe 2 to 3 months in order to build a robust model. Of course, we've done models with less, we've done models with more. It's kind of up to you to kind of evaluate your model, see if it's robust enough for you, that you feel confident in it.
Awesome. And one other question clarifying around the what if scenarios that you showcased during your demo. Can we run those what if scenarios on a model running on site?
Yeah, definitely. So you can definitely run model evaluation scenarios. So those what if scenarios, training scenarios, simulations on recent data. So as long as you have all the data available that your model needs, no data gaps, you can definitely run those kinds of scenarios on recent data.
Now, a couple of questions for Rex. You spent a lot of time showcasing some of the awesome features of the performance dashboards, but what if I want to deal with some of the data from the performance dashboards in another application? Am I able to download data from those performance dashboards for offline analysis?
That's a great question. So we're working on two different things that will allow this. One is an API that will allow users to access performance dashboard data in whatever tool that you would need. This is something we're working on in Q1. And we're also working on an option to download data per chart in a CSV file. And that's also something we're actively working on right now.
Awesome. Really exciting product development efforts. And then I've got one more question around the events report that you showed in those performance dashboards. That looks like a super useful way to capture institutional knowledge and different operator rationale for some of the different disengagement events. Mm-hmm. The question is, what kind of reasons would show up automatically in that events report?
That's also a good question. So things that will show up, reasons that will show up automatically are typically pre-configured conditions. So DLPC has engagement criteria basically for operations, and if any of these criteria fail, then DLPC will disengage, and the reasons will be automatically populated based on these conditions. So low feed, for example. And on top of that, operators can enter in reasons specifically for the events report as well. But that will depend on the operator's input, but those will be appended onto the reason.
Thanks, Rex. And I want to give another huge thanks to both Rex and Geraldine for joining me for today's webinar and delivering those awesome product demos. So stay tuned for more goodness to come in 2025 as our product team is hard at work, always improving the Imubit Industrial AI platform. And we'll catch up with you guys on the next webinar. Thank you.